All right, I found my TI-84, so I got this. Here we go. Particle moves along the x-axis. Okay, again, this right here, I know that when I take the integral of this fellow, and I plug in 0 for t, that it's got to equal 7. So no matter what, either c equals 7, or if I use this later, which we will, we're going to add 7 to it. That's what that's telling me. Okay, find the acceleration. That's simply the derivative of this at this time. So on our graphing calculator, you hit math and then number 8. That's our derivative. So here we go, dx, and now it's just trying to put this in correctly. X to the 6 minus 13, x to the 4th, plus 12, divided by, and we need the quantity 10, x to the 3rd, plus 3. So we close the parentheses, and it's evaluated at 5.1. That doesn't seem right. Oh, yep, that's because I didn't close that parentheses. Whoops. Let's try this again. Okay, insert a parentheses. Now we're gonna insert a parentheses right there. And that looks a lot better. 6.49. Yeah, that's right. All right, there we go. Get the parentheses right. Hello. Okay, for the second one, what we have to do is we have to graph the v of t, and we do it in absolute values because speed is always positive, and graph y equals 1. The question is, find all the values on the interval 0 to 2 for which the speed of the particle is 1. So to find this, we graph it. So you got, and that's the old one, my bad. Boom, so we have y equals 1 as one of our equations, and the other one is gonna be our v of t, which we just did. So let's make sure we do this one right. And we want absolute value, which is right there. Hit math, scroll over, number 1, absolute value. Okay, here we go. X to the 6th, minus 13, x to the 4th, plus 12, close parentheses, because we're not gonna make that mistake again. 10, x to the 3rd, plus 3, close those parentheses. Okay. I'm hitting zoom 6 because it'll show me just a 10 by 10. All right, so that's what the absolute value of that graph looks like. Boom, there's my 1 cutting across. But I'm only going from 0 to 2, so I can actually change this window and say, you know what, I don't care about that. Let's go 0 to 3. And I know it's gonna intersect at 1, so let's just make this 5 and negative 5 and be happy with ourselves. So here's what the graph looks like. Again, really zoomed in. Okay, so there's our two values. The question is, how do we find these two values? If you hit second trace or calculate, you can find the value not by hitting value, but by hitting intersect. Where are these two bad boys intersecting? So then on your first line, you see that cursor moving? Okay, so we're finding the first curve. That's this one. The second curve, now I'm on the y equals 1 line. I'm just trying to get it close. And there it is, 0.7718. Boom, and I do the same thing to find the second one. So number 5, I want it about right here. Yep, that's my guess, 1.4. Boom. So there's B. Then I do number C, letter C. Letter C says find the position of the particle at at t equal 4. Is the particle moving toward the origin or away from the origin? Okay, so right here, position is the integral, so we're going to add 7 to our integral at t equal 4. So we're finding the position of the particle at this time. So we find the integral of this particle, but we got to add 7 because it's basically the c. So we do that right here on the calculator. Math 9, 0 to 4, and we're punching in our v of t right here, which is x to the 6, once again, minus 13, x to the 4th, plus 12, close those parentheses, divided by, open those parentheses, 10, x to the 3rd, plus 3, close those parentheses, with respect to x, and then we're going to add 7 to that. 6.711. I believe that is the right answer. Now, then it asks, is it moving away or towards the origin? Justify your answer. Well, all we need to do is just plug in 4 into the v of t. And the question is it greater than or equal to 0? It ends up being greater than. You can plug in 4, but if you want to do it kind of fast, you can scroll up, hit enter, and it's going to pop that equation in again. And you can just hit delete. You scroll all the way over, you can hit delete on that, and then boom, you just have your equation. And you just punch in a 4 right there. Second insert will allow you to it allows you to punch in the 4 and stuff in there. And then this is going to be 10. Second insert. Just throw some parentheses in there so it makes sure it does what it needs to do. I'll make sure I punch in that equation right. Yeah. Plus 3, boom. Hit enter. 1.21. It's positive. We're moving away. Last one. D. It says, during the time interval from 0 to 4, not including, does the particle return to its initial position? Give reason for your answer. So the question is, does it ever hit 7 again? Well, we know here it hits at 4, at 4 it hits 6.7, so we know it goes less. The question is, does it go more than 7? Because it's continuous. We know it's continuous on that interval because the derivative exists over that time. So the question is it ever greater than 7? Is a integral of this guy ever greater than 7? So I'm just going to go scroll back up so I don't have to type it all in again. With that plus 7 in there, does this integral ever reach anything greater? So we'll change it to 1 and let's see. Beautiful. We could have guessed at 2 or at 3, and it's all about, here's 3. See, 3 wouldn't have done it. We'd have been like, I don't know, but we're just plugging it in and guessing. But because 1 was greater than 7, we knew we were good. So then it's just like, okay, 1 is greater than 7. T equal to 4 is less than 7, so the particle must return to 7 at some point, in between there, in between 0 and 4. So there it is.